Okay, so we've got the integral of arctan x from the bounds of 0 to square root of 3. So the first thing to notice here is that this is an integration by parts problem where we'll let u equal arctan x, and then of course du will be 1 over 1 plus x squared, and then dv in this case is just 1, therefore v with respect to x is just x. And so now we move on to the next step of IBP. We go across and then we go down. So we'll go across first and we'll have x arctan x from 0 to square root of 3 minus the integral of, we have x on top, 1 plus x squared on bottom, so x over 1 plus x squared dx, and this is also from 0 to square root of 3. The next bit I'm going to tackle is this portion here, this integral, and this is a quite easy to recognize u-sub. We have an item here on the bottom and its derivative on top, so if we say u equals 1 plus x squared, du in this case will be 2x, and then we'll put a dx over here. And now to make this look like x dx, we just have to divide by 2. So we'll move the 2 over there, rewrite the whole thing, x arctan of x from 0 to square root of 3 minus 1/2, that takes care of this du part, the integral from actually not 0. What we'll do is we'll say when x equals 0 and root 3, u now equals, when we plug these values into x here, we'll have u equals 1 when x is 0, and then when x is square root of 3, it's just 3. 1 plus 3 is 4. So now the new bounds here are 1, 2, 4, and we're just going to have 1 over u du to complete the u-sub. Moving swiftly along now, we've got x arctan x, still from 0 to root 3, I'll take care of that in just a moment, minus now 1/2. The integral of 1 over u is simply 1, or ln, absolute value of u, and this is now from 1 to 4. Now because we've converted these bounds from x terms to u terms, we can just plug them in. We don't need to replace u with 1 over x, or 1 plus x squared, which is what u stands for. We can just go ahead and plug the bounds directly in. Same thing over here. Although we didn't have to change these bounds whatsoever, they're ready to just plug in and play. So we've got square root 3 arctan square root 3 minus 0 for this x here. That'd be 0, so that's just going to null and void the remainder of it because it'd be multiplying by 0. So we'll just get rid of that. And we'll say minus, go ahead and put the 1/2 in, and then we've got ln, absolute value of 4, which I'm actually just going to write as parentheses 4 because the absolute values there would be redundant, minus, again, 1/2 ln 1, which of course we know is just 0 because the ln of 1 is just 0. So, in reality, what we've got is root 3 arctan root 3 minus 1/2 ln 4. And of course, arctan root 3 is just pi over 3. And you can see that by doing a simple triangle. If you say this is pi over 3 here, then what you've got is root 3, you've got 1, and then you've got 2. This also stands for 60 degrees. And the tangent of this is pi, square root of 3 over 1, which is what we have here. So this simplifies down to just pi over 3. So what we've got is square root 3 pi over 3 minus 1/2 ln, in parentheses, remember, 4. And that is the solution to this integral. If you've got any questions, or if you'd like me to tackle any other calculus or physics problems, please leave them in the comments below and I'll be sure to get round to them.